Let's take a look at equation of lines. Lines, of course, known as the linear function. And as we know, all straight lines can be written in the form y equals mx plus b, where m is the slope or the gradient. B, of course, becomes the y-intercept, because with any polynomial, the constant is the y-intercept. Alternatively, sometimes we have this, what we call general form. Ax plus by plus c equals 0. So we take everything all over to one side. Conventions are that A should be positive. I don't know that I necessarily agree with that, but I personally do always make it positive because I prefer it to be positive. But the other one that's often quoted, which is wrong, is that A, B and C must be integers. And that's not correct, because of course they could be surds. And how do you make a surd an integer? You can't. I guess what they're really trying to say is we don't have fractions in there. That's probably more to the point. So we're going to find the equation of a line perpendicular to y equals 5x minus 2, passing through 0, 6. Ooh, that's lucky, the y-intercept. In general form. Well, if it's perpendicular to this line, we know perpendicular lines, their slopes, that's it, negative inverse. The slope we want is minus 1/5, minus 1/5. And I can just put it straight into y equals mx plus b. We know the slope, we got the y-intercept, minus 5x plus 6. But they want it in general form, so there we go. X plus 5y minus 30 is 0. Now, all lines parallel to the x-axis must have the equation y equals some constant number. So there we go. You could still say, well, its slope is 0, so you could still say it's y equals mx plus b. And when you sub slope of 0 in, 0x plus the y-intercept. And, of course, lines parallel to the y-axis then, x equals k. All right, so that's just basic lines. Right, so exercise 5C.